MathSinger, yum!
Consider two circles that are tangent to a common line segment and to each other. Now, draw a third circle that is tangent to the line segment as well as to both the red and the blue circles. Can you determine the radius of the yellow circle in terms of the radii of the other two? I encourage you to hit pause and give it a try. I'll give you a hint. The solution depends entirely on using the Pythagorean theorem and a bit of algebra to analyze this rectangle and the triangles inside. Go ahead, try to solve it on your own. I'll be here when you get back. How'd you do? Okay, let's work on it together. We'll begin by finding the height of the rectangle that's drawn in the picture. Since the red circle has radius a, the distance from the center of the red circle to the line segment is a units long. But that's r units longer than the height of the rectangle. Therefore, the height of the rectangle must be a minus r. Using similar reasoning, we can see that the left side of the rectangle can be split into segments of length a minus b and b minus r. Now, let's work on the length of the base. The longer segment that makes up the base is the missing leg of a triangle whose other leg is a minus r and whose hypotenuse is a plus r. If we label the length of the missing leg as x, then it follows from the Pythagorean theorem that x squared plus a minus r quantity squared is equal to a plus r quantity squared. And by expanding a minus r quantity squared and a plus r quantity squared, we get that x squared plus a squared minus 2ar plus r squared is equal to a squared plus 2ar plus r squared. Subtracting the a squared and the r squared from both sides of this equation, we find that x squared minus 2ar is equal to 2ar. Then adding 2ar to both sides gives that x squared is equal to 4ar. And so x is equal to the square root of 4ar. Since the square root of 4 is equal to 2, it follows that x is equal to 2 times the square root of ar. Now, notice that the smaller segment that makes up the base of the rectangle is the missing leg of a triangle whose other leg is b minus r and whose hypotenuse is b plus r. If we label the length of the missing leg as x, then it follows that x squared plus b minus r quantity squared is equal to b plus r quantity squared. But this is exactly the same equation that we just solved, with length b replacing length a. Therefore, the solution will be exactly the same, but with b replacing a. And so it follows that, in this case, x is equal to 2 times the square root of br. Altogether, this shows that the length of our rectangle is equal to 2 times the square root of ar plus 2 times the square root of br. This turns out to be the length of one of the legs of the triangle in the upper left corner of our picture. The hypotenuse of this triangle has length a plus b, and we've already identified the length of the second leg as a minus b. It follows that the square of 2 root ar plus 2 root br plus the square of a minus b is equal to the square of a plus b. And recognizing that a minus b quantity squared is equal to a squared minus 2ab plus b squared, and that a plus b quantity squared is equal to a squared plus 2ab plus b squared, we can rewrite this equation as 2 root ar plus 2 root br quantity squared minus 2ab equals 2ab. In other words, 2 root ar plus 2 root br quantity squared is equal to 4ab. And since 2 squared is equal to 4, we now have that 4 times root ar plus root br quantity squared is equal to 4ab. In other words, the square root of ar plus the square root of br quantity squared is equal to ab. By factoring the square root of r from both terms on the left And then recognizing that the square of a product is the product of the squares, we see that r times square root a plus square root b, quantity squared, is equal to ab. Finally, dividing root a plus root b, quantity squared, on both sides reveals that the radius of our yellow circle is equal to ab divided by the square of root a plus root b. This problem was inspired by a video that was produced by PreMath in 2021, in which he challenged his viewers to find the radius of the yellow circle in the specific case when the radii of the two larger circles were 4 and 2. Letting a equal 4 and b equal 2, the general solution that we found together gives that the radius of the yellow circle in this specific case is equal to 4 times 2 divided by the square root of 4 plus the square root of 2, quantity squared. This is equal to 8 divided by 2 plus root 2, quantity squared, which agrees with the solution that PreMath obtained. You can find a link to PreMath's 2021 video in the description below. If you like this video, please remember to subscribe to this channel by clicking on the link to the right. For now, thank you for watching, and I'll see you in the next video.